We don't have time for that. We got to get class started. Welcome to algebra, everyone. I hope you had a great weekend. I'm excited. We're getting close to the end of the semester. We just got to get through a few things first. But before we get started, let me put this up and get your opinion. You can put your answers in the chat. Here we go. All right, which pizza describes how you're feeling this morning? Full, half eaten, third eaten, only a slice, empty plate. Oh, yeah, I know we're getting to the end of the semester, right? I feel kind of half-eaten myself. I got to say, I mean, got a lot juggling, trying to get everything wrapped up, trying to get grades in, trying to get everything graded. I know you guys are turning in missing work, trying to get all that caught up. Hey, let me see in the chat there. Oh, Robert's feeling full. Good job, Robert. You must be caught up and get some sleep. Empty plate. Bryn's got an empty plate today. She's burning it on both ends. It's like that. Third eaten. Oh, that half eaten. I see a lot of people in the middle here. A lot of half eaten, third eaten. All right. Well, I'll tell you, just pull it together. Let's get to the end of the semester. We got a nice break coming. So, try to get some rest in there. I know you're busy too, but let's get started. So this week we're continuing talking about quadratics, and we're continuing different methods of solving quadratic equations. As I've said many times, there are many ways to do things in math. There's many ways to solve things. And so we're going to look at two more ways of solving quadratic equations. We've looked at factoring and completing the square and those things. We're going to look at the quadratic formula today, as well as graphing, because graphing is a wonderful way to tell us a lot of information about an equation. So get your pencil and paper out, get ready to take some notes. Remember, you can always use your notes on tests and quizzes and assignments. And it's always good to have some examples written down with your notes. So get your pencil and paper and let's do this. Okay, here we have the quadratic formula. And the quadratic formula can be used to solve any quadratic equation. So the formula goes x equals, so this is telling our solutions, our x's, negative b plus or minus the square root of b squared minus 4ac over 2a. Now, where do we get this ABC? Now, the quadratic formula only works when a quadratic equation is in standard form, and this is what standard form looks like. F of x or y equals ax squared plus bx plus c. So that's where we get our a, b, and c from the standard form of a quadratic equation. So we have to have it in this form. We can't have it in vertex form or factored form. If we have it in factored form, we multiply it together to where we have just f of x equals ax squared plus bx plus c. So for example, if we have, and remember, f of x is the same as y. If we have y equals, and let's say 2x squared minus 3x minus 5. All right, so that's a typical quadratic equation we might see. And so with that, the quadratic formula can solve what are the solutions to this. Now, how many solutions does this have? Put that in the chat. How many solutions are we expecting? All right, very good, Emery. Very good. That's right. 2 solutions, because remember the fundamental theorem of algebra says whatever the highest exponent is how many solutions it has. The highest exponents are 2. We're going to have 2 solutions with a quadratic equation. So let's see. I've color-coded this for a reason, because we have to use the coefficients in the quadratic formula. So make the red 2, because that's our A. We have a negative. Don't forget the negative goes with the B. And the negative is going to go with the C also. So negative 5. So let's work this and see how this works. So what are the solutions? So the solutions for this are x equals negative b. Now b is a negative already, so I'm gonna write that like this: negative 3. Just to remind us that since b is a negative, we're going to have to do something with that. All right, plus or minus the square root of b squared. So this is negative 3. And I put that in parentheses because that's important. If we don't put the parentheses, we might just square the 3 and forget that it's a negative 3. Minus 4 times, what is A? A is 2. So I'm going to put it in parentheses, multiply it times 2. And our C is a -5. Now, all of that, I need to extend this out. All of that is under the square root. And that is all over 2 times, and our A is 2. 2 times 2. All right, let's simplify that. X equals, and I'm not going to put it in colors here because we're just simplifying now. So -3 equals what? What is that? Put that in the chat. Right. Good job, Jan. That is a +3. So we don't have to put the plus. It's just a +3, plus or minus. Now let's simplify everything underneath there. Now everything underneath this b squared minus 4ac is called the discriminant. I'm going to write that out. Discriminant. And we're going to talk about the discriminant in just a little bit. So I just wanted to make you aware. B squared minus 4ac is called the discriminant. That's just a part of the quadratic formula. -3 squared. What is -3 squared? All right. Well, that's -3 times -3. And a negative times a negative is a positive. So we have a +9. Minus 4 times 2 is 8. And 8 times -5, this is minus a -40. All right. Or we could have taken -4 times -5 times 2. 9 minus -40. And all of this is over 2 times 2, or 4. All right, let's continue on. So this is 3 plus or minus. What is 9 minus -40? Well, when we subtract a negative, that means we add. So this is the square root of 49. And all over 4. So this simplifies. Square root of 49 is 7. Well, it's 7 or -7, but we've already taken care of that because we're talking about plus or minus. So that takes both things into account. So this is 3 plus or minus 7 over 4. Almost there. We said it had 2 solutions. This is 2 solutions because this is 3 plus 7 divided by 4, or 3 minus 7 divided by 4. See, we take the plus and the minus, and that's 2 different solutions. So 3 plus 7, 10/4, which is the same as 2.5, right? If we're graphing it, we would look for a solution at 2.5. And this is -4 over 4, which is -1. So our solutions are 2.5 and -1. You know, this would simplify to 5/2 if we left it as a fraction. And that's the 2 solutions for this quadratic equation. Now I want to look at something on that. Let's graph that. And what does that look like when we graph it? Okay, so we can put that equation in Desmos. Y equals 2x squared minus 3x minus 5. Okay, so there's our equation. And let's see, the solutions we said were -1 and 2.5. Look at that. That is where the graph crosses the x-axis. That's why the solutions are also sometimes called the zeros of a solution of a quadratic. You know, the zeros of a quadratic equation, or the solutions of a quadratic equation, because that's where the equation equals 0. So we could have taken a shortcut on this one and just simply gone and graphed it and found the solutions. A nice visual shortcut to do that. But let's go over one other case here. Let me put a different equation up here. How about if we have an equation like this? 4x squared plus 4x plus 2. Let me turn off the other one. What's the solutions to this equation? Oh, don't know. Now, it is a quadratic equation, right? You see the x squared. So there are 2 solutions. The fundamental theorem of algebra tells us there's 2 solutions. But when we graph it, we don't see anywhere that it crosses the x-axis. Why is that? Why do we not see a solution? Put that in the chat. Somebody take a guess. Yeah, no, you don't know. Take it. Royal, what? They're imaginary. Yes. Yes, they're imaginary solutions. If the quadratic equation has imaginary solutions, they're not going to show up in a graph. We'd have to have a special graph that shows imaginary numbers, and that's not something we can do very easily at all. So when we graph the quadratic equation and it does not cross the x-axis or touch the x-axis at all, that tells us they're imaginary solutions. And remember, and if we have an imaginary solution, you always have two. They always come in pairs. Imaginary solutions have to have a buddy. So how can we find the solutions to that? Well, we just had the quadratic formula. Let's go back and take a look at what the solutions are with the quadratic formula. So we had that equation again, 4x squared plus 4x plus 2. I'll put y equals out there. Okay, can you do this without the color-coded? All right, try this in your notes. Let me give you a moment to get started. Write down the quadratic formula using the coefficients from this equation. And then I'll write it down. You can check your work to see if you set it up correctly, because that's the important part. You got to set it up correctly. All right, I'm going to write slowly here to give you a chance to be ahead of me. Check your work. Negative b, negative 4 plus or minus the square root of b squared. 4 squared. I didn't do parentheses because it's not a negative. So I didn't really need them. Minus 4 times a. A is 4. C is 2. A, B, C. All over. You got that? What? Yeah, it's 8. It's 2 times 4. Okay, so let's simplify that. Negative 4 plus or minus the square root of, what does this calculate to be? 16 minus what? 4 times 4 is 16 times 2 is 32 over 8. So that equals negative 4 plus or minus 16 minus 32, square root of negative 16 over 8. Square root of negative 16, that is an imaginary number, right? Before high school, we would just say that's no solution. There's no such thing as the square root of a negative number. But now we know that the square root of negative 16 is 4i, an imaginary number I, right? Because it's square root of negative 1, which is I, times the square root of 16, which is 4. Sorry, it's off your screen there. Square root of negative 1 times the square root of 16 is the square root of negative 16, which is 4i, because this is I, this is 4. So negative 4 plus or minus 4i over 8. We can simplify that because anytime you have something over a fraction, you can break it out into two fractions. If you have a denominator, plus or minus 4i over 8. See, and now that simplifies. So this is negative 1/2 plus or minus I divided by 2, or 1/2 I. Either way you want to write that. But that is our solutions, and they're imaginary numbers. You know, negative 1/2 plus or minus I divided by 2. That's why we don't see that when we graph it. Now, I talked about this discriminant up here. The discriminant will tell us one thing right away. If you're like, okay, so I have to graph it to figure out if it's an imaginary solution. No, you don't. You don't have to. You can use the discriminant right here. If the discriminant, in this case, the discriminant ended up as a negative number. If the discriminant equals a negative number, the solution, I'm sorry, I didn't get that part. If the solution is a negative number, that means it's imaginary. I is going to be in your solution. It's imaginary. So you know right off that you could have imaginary solutions. If you just look at the discriminant portion, you could just do the b squared minus 4ac and figure out right away, am I going to have negative solutions? So, all right. Questions on that? Again, remember, we can always graph it and know if it's going to be imaginary solutions. To solve it with the quadratic formula, you have to have it in standard form. Fill in your A's, B's, C's, and simplify until you get the two answers. In this case, 2.5 and -1. And remember, you should be able to graph it to check yourself. If you did the quadratic formula, you want to check it, go check it out. Make sure that those zeros where it crosses the x-axis are at the numbers you calculated. Okay, you got your assignment in Google Classroom. You have 10 problems to practice. 10 practice problems. Have those done by next class. Find the solutions. All right, as you leave, I just put a poll up here. Answer this poll before you leave class, and then we'll see you next time.